Assalamu alaikum everyone. I am Shahriar Siam, a student from American International University, Bangladesh. Today I am presenting a digital parking control system. The goal is simple. We track how many cars enter and exit, and the system automatically shows full when the garage reach maximum capacity. Otherwise, it blinks space available. Moving on to next slide, which is our first task. First, we build the block diagram. We use entry and exit sensors to detect cars, a counter to track the count, and a comparator to check if we reach the maximum capacity. Based on that result, we activate either the full display or space available display. Next comes the flow diagram. We start with count 0, set the maximum capacity, and continuously check sensors. Each entry increases the count, each exit decreases it, and the display update instantly depending on whether the count hits the limit. This part focuses on decisions. Did a car enter or leave? If yes, we update the counter. If not, we keep monitoring. So the system works continuously in real time. Since our maximum capacity is 13, a 4-bit counter is enough because it can count up to 15. This makes the hardware simple and efficient without needing extra bits. Here we show how the counter moves through binary state. Every car entry pushes the count forward and every exit brings it back. This binary sequence is what the comparator uses to detect when we have reached capacity. To build the counter physically, we connect flip-flop in a chain. Each flip-flop represents one bit and together they form a full 4-bit counter. This is the core memory element of the whole system. Moving on to JK flip-flop truth table. Since the counter is flip-flop based, we used a JK flip-flop table. This helps decide the correct J and K inputs so the counter toggles properly and stays stable during transition. This one is the up table and this one is the down table. Moving on to task 2. Now we move to controlling the display using two 555 timers. One timer controls the continuous full display and the other controls the blinking space available display. So we get both stable and blinking outputs as required. For the full case, the display must stay on continuously, so the timer output stays steady without blinking, ensuring the word full is always visible once capacity is reached. When space is available, we want blinking to attract attention. So here we use an adjustable timer configuration which repeatedly switches on and off, creating the blinking effect. Moving on to the next slide. In this slide, we apply the given formulas for duty cycle and frequency. The key idea is we select resistors and capacitors value so the blink rate matches the required timing. These are the equations and calculations. Calculations for capacitor. In this slide, we choose 250 microfarad because it gives balanced resistor values. With 50 microfarad, the resistor becomes too large. With the 470 microfarad, they become too small. So 250 microfarad gives the most practical circuit design. Using the selected values, we compute the timing. The display stays on for about 63.33 ms and off for about 19 ms. That creates a clear blink that noticeable but still smooth. Moving on to next slide, which is our task 3. Uh, Here, to avoid glitches, we add extra sequence logic that counter ensures accurate car tracking, and logic gates help the system switch between full and space available without flickering conflict. Uh, in this slide, the state tables summarize how the system behaves for different range of cars count. It clearly shows which display activates at which count, making the design easier to verify. The state diagram visually represents the same behavior. It shows how the system transitions between space available state and the full state depending on entry and exit sensor events. This is our Verilog HDL code. Moving on to task 4. Now for limitations, the biggest issue is scalability. A 4-bit counter limits us to 15 counts, so our system max is 13 cars. Also, sensors may bounce and cause incorrect counting, and the blink timing is fixed by hardware components. To upgrade for larger parking areas, we can use a 5-bit counter to increase capacity. Adding filters and better logic improves accuracy. The trade-off is more hardware complexity and slightly higher power consumptions, but the system becomes more reliable and scalable. And this is the impacts. That's all for today. Hope you enjoyed it. Assalamu alaikum. Goodbye.